All right, let's look at graphing this linear equation. I want you to be careful to read the instructions. If you're told to use intercepts, make sure you do so. That means we're going to let x equal 0 and y equal 0. So we have 1 point where y is -5. And when y is 0, again, if you haven't done this question already, pause the video. The first thing we're going to do is open the brackets. We want all of our terms with x on one side. And all of our terms without x on the other side. Divide by 16. X is less than or equal to -1. So we put -1 on our number line. Less than means we're shading towards the left. Less than or equal means we need a closed or square bracket. In interval notation, remember that we're always going from our lowest value to our highest value. Lowest is -infinity, highest is -1. Infinity always has a round or open bracket. -1, we already said, is closed because it is less than or equal. When you're simplifying radicals, sometimes, like in this case, it's easier to think of this as two separate radicals. Because I know the square root of 16 is 4. 75, we can prime factor. We have 2 factors of 5, and because the index is 2, I know I can take those 2 5s outside of the radical sign. 5√3 all over 4. Why don't you prime factor this one and simplify it? I want to say something about the way I have this written here. If you look at that top radical sign, it doesn't cover all of my factors, and it needs to. Be careful about that because we are looking for that. Again, the index is 2, so we're taking out 2 3s from the numerator, and we know the square root of 49 is 7. When I take factors out, we multiply them. 3 times 3 is 9, √5, all over 7. And just a reminder, I haven't been doing this, but when you've finished, it does help if you put a box around your final answer. We're multiplying binomials. That means that each term in the first bracket, the root 13, is going to multiply the second bracket, and then plus √3 is going to multiply the second bracket. Because these were all prime numbers, I just went ahead and multiplied root 13 times root 7, root 13 times minus root 3, root 3 times root 7. But now we have root 3 times negative root 3, positive times a negative, but root 3 times root 3 is 3. I don't have like radicals here. I know I can't simplify any further because I was multiplying prime numbers. This one is finished. Go ahead and try the next one if you haven't already. When I multiplied 4 root 13 times 13, remember that that 4 is multiplying the 1 outside, and then we had root 13 times root 13, which is 13. So 4 times 13, 52. I have like radicals here, so we can combine those. Negative 32 plus 1, negative 31 root 13. And of course, I have to combine those constants. 52 minus 8, 44, minus 31 root 13. If you have difficulty with any of these questions, be sure to ask me or your instructor before the test that you have this week so that we know you're good with these questions. All right, we're solving an equation. The first step is, of course, to factor the denominators because we want to try to find the lowest common denominator. When we're looking for the lowest common multiple of the denominators, we have to look at each factor. I could see that I need a 3 and a y plus 3. I also need a 2. I'll put it up there. We already have the y plus 3. So the lowest common multiple of our denominators here is 6 times y plus 3. Now, I've noticed that a lot of you just prefer to find a common denominator for all of our question here. So if we're going to do that, we have to multiply by whatever's missing. If I look at this first fraction, I see it has the 3 and the y plus 3, but it's missing 2. If I look at the next fraction, I see that it has 2y plus 3, but it's missing the 3. Again, we're multiplying the numerator and the denominator. And our last expression has the y plus 3, but it doesn't have the 2 or the 3. So we need to multiply by 6. Now I have a common denominator here on the left of the equal sign and a common denominator here on the right of the equal sign. In my numerator, 2 times 2y, and don't forget you're using your distributive property here. Oh dear, 51, I hope so. That equal sign doesn't look very good. And again, using the distributive property. When you're solving an equation and the denominators are the same on both sides, we can ignore them. And we can go ahead and just say that our numerators are equal to each other. So I'm going to ignore the denominators. Let's see, 25y minus 51 equals 6y minus 108. Now I can put my y's on one side, my numbers on the other side. Seems like a lot to ask here. 8 minus 1. I do hope that's right. Divide by 19. When you're solving a rational equation, an equation that has a variable in the denominator, you have to check. When I look at the denominator, I see that y plus 3 can't equal 0. That means that y can't be -3. Y equals -3 is the solution we found. That means that this question has no solution. That -3 would make our denominator equal 0. Here's another equation. If you haven't already done so, why don't you factor the denominators and find the lowest common multiple of the denominators and decide what you're going to multiply each term by. So you should have found that the lowest common multiple was x minus 2 and x plus 7. The first fraction was missing that factor of x minus 2. The second fraction wasn't missing any factors in the denominator, and the final one was missing x plus 7. And again, now that the denominators are all the same, we can ignore them. And I'm just going to go ahead and open the brackets in the numerator. Now I've opened all of the brackets, but I want you to be careful. We have a subtraction sign. That means we're subtracting this entire product. This is a quadratic equation. We want it to be equal to 0. Again, we need to check our denominators. We need to go back to the beginning of the question. And we see that x minus 2 cannot equal 0. X plus 7 cannot equal 0. So x can't be 2 or -7, but we can have x equals -51 and x equals 1. If you're still having trouble factoring quadratic trinomials, make sure you spend some time with those. Here we're just being asked to add and subtract. And remember, when you're adding and subtracting fractions, you need a common denominator. The first thing we need to do is factor the denominators. We've factored the denominators. We see that we need an x plus 3, x plus 1, and x plus 2 in the denominator. In the first term, x plus 2 is missing. So we have 9 times x plus 2. In the second term, we see that x plus 3 is missing. So we're going to multiply by x plus 3. And in the last term, we see that x plus 1 is missing. So we're going to multiply by x plus 1. Remember, when you're multiplying by binomials, you need to have brackets around the entire binomial. Sometimes you're told to leave these questions in factored form. Do not stop here. You have to open the brackets, combine like terms, and then check for any factoring in the numerator. So notice I've opened the brackets in the numerator. You don't need to open the brackets in the denominator. I've combined like terms, and I cannot factor that quadratic trinomial in the numerator. This question has been simplified, and it is in factored form. Why don't you try this one if you haven't already done so? Now, we've found our lowest common multiple of the denominators. I needed a factor of x plus 2 and x minus 2. I have them. I need two factors of x minus 2. We have them here. And we needed x minus 5 and x plus 2. So there are four factors in the lowest common multiple of our denominators. So we need to be careful now. When we're looking at that 5, it has x plus 2 and x minus 2 in the denominator. I need another factor of x minus 2 and a factor of x minus 5. Can you determine what's missing for the other two terms? Did you find these as your missing factors? When you go to open these brackets, I would suggest you multiply the binomials first and then multiply by the coefficients in front of each one. Now, I haven't been writing in the denominators. I'm just being a little bit lazy here. But there's a lot to write. I've opened the brackets. I've multiplied by the coefficients in front. Now we just need to combine like terms and decide if we can factor. So here's the final answer for this one. These questions are always on your tests, always on the exam. Make sure that you practice them. All right, simplify. In these questions, we always want you to leave your answers with positive exponents. I'll give you a minute to get that done. Actually, there's two of them here. You should have these papers already from your teacher, so you should have them in front of you. Hopefully the work is done already.